Let us look at Physical Sciences, Paper 1, November 2022, Question 4. We are focusing on Question 4 here, which is momentum. Without any waste of time, let's tackle these questions here. Now, look at this. It says Question 4, trolley X, which has a mass of 1,2, travels at 8 meters per second east. So we are given direction here. Remember that velocity is a vector quantity. It must have the magnitude and what in direction. It then collides with trolley Y. Trolley Y has a mass of what? Of 0,5, which is initially at rest. Once I see rest, I know that velocity there is what? Is 0. Okay, we are ignoring the what? All the effects of what? Of friction. Now the examiner here is giving us the velocity versus time graph below, shows the trolley X before and during and after the collision with trolley Y. All right, so now let us check to see the graph. So we can see the graph here. Remember that the graph is only for which trolley? For trolley X. We are given velocity on the x-axis and we are given, no, in fact we are not given velocity. On the x-axis we are given time, but on the y-axis we are given what? We are given velocity. Now this is X. X was moving at what? At 8 during collision. Now before collision it's 20, and then after that what do we have again here? We have 20, what? 20,2. This is the time here that we have. So the velocity was 8 here. We don't know the velocity during collision. We should know it because it's what? It is 4. So it decreased in what? In velocity. All right. So let us look at our question now. Let us look at our question. All right. We are looking at 4.1. We are tasked to state the principle of conservation of linear momentum, which is 2 marks there. Remember here you can get 0 or 2. You can't get 1. Then how do we then state the principle of conservation of linear momentum? We say that in an isolated system. Now, if the system is isolated, we should know that is the same as closed. So in a closed system, the total linear momentum is constant, or you can say is conserved. It is conserved. Whether you say constant or conserved, or with constant, in fact, you can say that it remains constant. It remains constant. So it remains constant. So in the exam, if you say in an isolated system, the total linear momentum is conserved, you are correct. Or you can say in an isolated system, the total linear momentum remains constant, you are correct. You get your 2 marks. Let us now move to the next question. The next question now is 4.2. Now in 4.2, we are tasked to calculate here. Calculate the magnitude of the velocity of trolley Y immediately after what? After collision. All right, so now they will collide, so we need to find the velocity. Now, this linear momentum is conserved. So sum of momentum before should be equal to sum of momentum after. So we can say that sum of momentum before, which is, we can say I, equal to sum of what? Of momentum what? Momentum after, which can be final. Now what do we know about momentum? Momentum is the same as mass times velocity, but we must be specific here. We are looking for what? For the velocity of the trolley Y immediately after what? After collision here. So it's the final velocity. So we have mass of X. We have mass of X and Vi of X. In fact, this is not visible. We can just say we have mass of X, and then we have Vi of X plus V, in fact not V, we have plus mass of Y, Vi of Y, which will be equal to mass of X, but now is Vi F of what? Of X plus mass of what? Of Y, VF of Y. Now, do we know the masses here? We go to our question here or our diagram and see if we have the masses. Oh, from our statement we were given the masses. Trolley X is 1,2 and then trolley Y is 0,5 and then we have 8 meters per second. But remember here for trolley Y it was at rest, is 0 meters per second. So we can take it from there now. We can take it from there and see what we can write here. Now, the mass for X, we said is what again? Let's verify for the last time. We said is 1,2. So let's look at this now, 1,2. So we can come and say, this is what? It's 1,2. So we can do it like this, 1,2. What is the velocity then? It is 8. Remember to choose direction here. So I am choosing what? East as what? As positive. East as positive. So I have 8, which is positive, plus the mass of the what? The mass of trolley Y, which was 0,5. But remember that the velocity of Y is 0 because we say it was at rest. Now mx did not change. The mass is still the same. We have 1,2, and therefore the velocity when it was colliding, we can look at the graph here. This is the velocity. So we have what? We have 4 there in the same direction. So we can just put our 4 here. It's still positive, plus we have 0,5. We don't know the what? The velocity after or immediately after what? They've collided for Y. So we can say what here? We can say VF for Y. We don't know that. From here, I think what we can do, we can just use our calculator and therefore we get our answers here. Obviously here, what we have is 0,5 and 0. It will give me 0. I must go to my calculator now and therefore look for 1,2 times 8. What do I get there? 1,2 times 8. I have 9,6. So 9,6. And then equals to, what is 1,2 times 4? We go to our calculator. 1,2 times 4. Now 1,2 we times 4 here. What do we then get? We get 4,8. We have 4,8, which is plus what? Plus 0,5 VFY. Right, we can take this 4,8 to the other side. What do we then get? In a calculator, we can just say 9,6, which was given, 9,6 minus 4,8. What do we get here? In fact, that's not 4,8. We can repunch that. 9,6 minus 4,8. What do we get here? We are getting 4,8. So we have 4,8, which will be equal to 0,5 VFY. We divide both sides by 0,5. So we can go to our calculator now and say 0,5 divided by, in fact, 4,8 divided by what? 0,5. So 4,8 just add divide by what? By 0,5. Okay. What do we then get there? Our answer then becomes 9,6. So the velocity VF of Y is going to be 9,6. It is meter per second. Meter per second, 9,6 meter per second. That is our speed there, or the velocity. We then move to the next question. The next question now, we are looking for the average net force. The average net force, so is the average net force that trolley X exerts on what? On trolley Y during what? During the collision there. So what can we do now? Our formula is F net equal to change in momentum. We can expand this formula. In fact, it is not F net. Something is missing here. One can say it is F net change in time. That's our formula. We have F net change in time. Please be careful in the exam as well. Do not omit change in time equal to change in what? Change in P. We can expand this change in P by saying F net equal to, see, I'm omitting again the time here. Don't do this in the exam. You're going to lose marks. Change in time equal to mass in bracket VF, final velocity, minus what? Initial velocity. All right. We are looking for this F net. Do we know the time then? Do we know the time there? We go to our what? We go to our graph. We go to our graph there. Our graph will give us the time. Let us look at this. So the time now is the difference between 20 and what? And 20,1. The difference between the two is 0,1. So that is our time now. That is our time. So we have our time. So F net, what is my time then? 0,1 equal to, do I know the mass now? The mass of this block is 1,2. So it's 1,2. And then now, in bracket, do I know the final velocity? Yes, final velocity immediately after collision, we do have what there? We have 4, we have a minus. It began with what? With 8. So we have that. From now on, we just calculate, and therefore, we know that 1,2, 4 minus 8, I'm going to get minus what here? Minus 4. Minus 4. And therefore, here we still have F net and what? And my 0,1. What do we then do? We just multiply what? We just multiply 1,2 and negative 4. We go to our calculator. We go to our calculator here now. Our calculator is saying 1,2. I can just put my calculator on the side so we can all see. 1,2 I multiply by negative 4. Don't forget it's negative 4. Now what am I getting here? I'm getting negative 4,8. Negative 4,8. Negative 4,8. I still have F net here, and I still have 0,1. We can divide both sides by 0,1. What is my F net then? We go to our calculator. We say 4,8 divided by 0,1. That's what we do there. 4,8 divided by 0,1. 4,8. Look at this. We have 4,8. We divide by 0,1. What do we then get? We have what? We have 48. But remember that the 4,8 was negative. Therefore, my answer will be negative as well. So this will be negative what? 40 what? 48. Don't forget the what? The unit measurement for what? For force, which is what? Which is Newton. Do we leave it like this? We can't have a negative force. This means that in the opposite what? Direction. Therefore, F net can then be what? Can then be 48 what? Newton, because you can't have a negative force. Let us now look at 4.3. We are asked here, is the collision here elastic or inelastic? So the collision here, we don't know whether it's what is elastic or inelastic. My advice to you, grade 12, is that just do calculations, do calculations here. If you find that your in fact, your sum of kinetic energy for trolley X is equal to sum of kinetic energy of trolley Y, you can then say it is what? It is elastic. But if they are not equal, you can say it is inelastic. So my advice to you here, you do calculations. We can start with trolley. Let us start with trolley X. Now for trolley X, we know that sum of kinetic energy at X, this will be 1 over 2, just fix that quickly, 1 over 2, okay, 1 over 2 is the mass and the initial velocity. We have the initial velocity, okay, and then we have, in fact, the final velocity here. Let me just fix that for you. the whole thing. This will be 1 over 2. It's 1 over 2. We have the mass, we have the final velocity minus, don't forget, squared. 1 over 2, we have m for x, and then v, which is the initial velocity, squared. Do we have the values now? I think so. We have 1 over 2. What is the mass of trolley x? It was 1, 2. We just plug in that. What is the final velocity of what? Of x? We have 4, which is squared, minus 1 over 2. We still have the same mass, which is what? Which is 1, 2. And therefore the final, the initial velocity, here it was what? It was 8. We say squared. All right, from here we go to our calculator. We punch, and then we get our answers here. Okay, so what we can do here is, let me just move my calculator so that we can all see. And then here I have 1 over 2. So what I normally do here, I can just say 1, 2, because I know that is half. And then I have 4, and then I have squared, right? The answer I get here, I divide it by 2 because it's half of that. And therefore, what do we get here? We have 9,6. So I have 9,6. I must come and say, I got 9,6. All right? It's minus. We can also punch on the other side. What do we have on the other side there? Okay. We have, can just move it for you so you can see here. We have 1, 2, right? 1, 2. 1, 2, what are we multiplying with here? With 8. Don't forget that the 8 is what? Is squared. The answer I'm getting there is 76,8. But remember, I did not include the 1 over 2, so it's half of that. I divide by 2. What am I getting now? I'm getting 38,4. So I can come and say 30 what? 38, what? 4 on x. Now, what is minus? In fact, what is 9,6 minus 38,4? We come to our calculator here. We know that we can say, I'm not sure if you can see that. We can say, just move it here a bit so you can see. We can say 9,6 minus 38,4. What do we then get here? Our answer is negative. My answer is negative. Negative what? Negative 28,8 joules. So I have my sum of EK at x equal to negative 28,8 joules. This 8 here is not visible. We can just change that. So what do we have here? We have negative 28,8 joules. Are we done? We are not done here. What we must do is we must then look for the sum of kinetic energy on y. So we can say that we are looking at y now. So it's sum of EK, where at y, which will be equal to 1 over 2, the mass, the final velocity of y. Don't forget to square. It's going to be minus 1 over 2. What do we then have here? We have the mass and the initial velocity. So we have the initial, let me just fix that. We have the initial velocity, so it's mvi squared. Okay, we have 1 over 2. Do we know the mass of trolley y is 0,5? Do we know the final velocity? We just calculated the final velocity. We calculated it somewhere here. We can just go and check it. It was 1,9, in fact 9,6. So we just take that and say we have 9,6, which is what? Squared. And therefore minus 1 over 2. Do we know the mass of y? Yes, 0,5. And therefore, do we know VI? Our VI here was 0 because it was at rest. So I know already that this side is minus 0. Now, we punch on our calculator. We can come here and say, on our calculator, we can come here and say, I just want you to see this here. We can come here and say 0,5, right? And therefore 9,6. Don't forget to square it. And then the answer I get here, I divide by 2 because it's half. So I divide by 2. What am I going to get here? I am getting 23 23,04. I'm getting 23,04. 23,04. So let's look at this. 23,04. 23,04. I'm going to take it down, which is 23,04. And therefore, my final answer is sum of EK at Y is the same as what? As 23,04, which is joules. Now, when I compare the two answers, I can tell that sum of what? Sum of what? Of EK at X is not equal to sum of what? Of EK at what? At Y. And therefore, what is my final answer? This is what? This is inelastic. This inelastic. So it's inelastic because they are not equal. That's how we do this question. This was 4.3. That's how you get your full marks on 4.3. And then grade 12, that's how you answer 4.3.